Thank you for joining our session. I'm Masami Hiramatsu, a senior tech lead in Linaro. Today, I would like to make a talk about the SystemReady best practice with Paul Liu. The session will start from Paul's slide. Thank you.
Hello, I'm Paul, and I work for Linaro as a senior software engineer. Today, I'd like to share some experience of getting CompuLab IoT Gate IMXX certified by the SystemReady IR and some status from NSP. So for my project, the target hardware is CompuLab's IoT Gate IMX8. The SoC is IMX-AM Mini. Memory size can be customized when purchased. So it is 1 GB to 4 GB. And there's RTC, hardware RTC on board. So when we implement the EFI get time and EFI set time, we can use the hardware RTC rather than an emulated one. And the board can be added with TPM2 hardware, so major boot is able to be implemented too. The firmware we got certificate is the mainline U-boot TFA and UPT. So here is the status of the SystemReady IR certificate of the CompuLab's IoT Gate IMX8. The firmware version is, as mentioned, the mainline version, and it passed the SystemReady IR version 1.0 level 1, so it can directly install Fedora IoT 34, OpenSUSE Leap 15.3, and Debian Bullseye. So you just download the installer from the distros page and put them onto the USB stick and boot for installation. So for CompuLab's board, we did the following tests. So first, we enable the TBBR in TFA. The original BSP from CompuLab is SPL boots into the BL31 and then boots into U-boot. While we enable the TBBR, so that means our boot sequence is SPL to BL2, and BL2 verifies BL3 13233 in FIP. So for U-boot, we upstream the support of the board, and also porting the hardware RTC driver for the U-boot. So we can use hardware RTC and EFI get time and set time service. We also enable capsule updates for updating the firmware, and we maintain the DTS that can boot both U-boot and Linux kernel in U-boot. So for distros, we first make sure the mainline kernel boots, and then we compare the diff config used by the distro and mainline, and the firebox to add distros to enable it for our hardware. And here is the status of NSP's IMX-AM EV board. The SoC is the same, IMX-AM Mini. NSP certified their pre-release firmware, not the mainline version. The certificate is SystemReady IR v1.0 level 0. The difference between level 0 and level 1 is for level 0, some modifications need to be applied to distro installer images. For level 1, it's not perfect, though we don't need to modify the distro images, but we need to apply some workarounds to the firmware. On CompuLab, the major problem is we have to disable CPU idle functionality in U-boot, DTS, and boot ops. The interesting thing is that in this CPU idle issue is not happen on NSP's pre-release firmware. That means there are some downstream patches exist in the firmware. But we all know that NSP is doing great on upstreaming their patches, so by time we can expect that we finally can get level 2 certificates someday. And here are foreseen and some thoughts when we are developing our firmware. So the DTS now is provided by the firmware that is required by the SystemReady IR certificate, but not from the Linux kernel. However, one DTS can boot a version of kernel doesn't mean that you can boot another version of kernel. To make sure we didn't break the mainline, the only solution is to keep syncing DTS from kernel periodically. But a better mechanism is we should avoid DTS breaking, just like Linux kernel promised not breaking the user space. For DTS, there should be some similar mechanism, so we can have a DTB that boots various kernel versions, and U-boot has -U boot .dtsi that modifies something for U-boot. And this is also needed to be handled carefully, like we shouldn't delete node and properties used by kernel. And we should avoid introduce conflict properties with kernel. And for upstream downstream changes, for example, U-boot and TFA, sometimes we found that the one in BSP runs better than the mainline. But mainline has the features that needs by the SystemReady IR certification. For example, some EFI service in U-boot or TBBI in TFA. And for kernel, not only the versions is different, the diff config used by the mainline and distro could be different too. So we need to look into a distro, test the distro kernel, and carefully report the bugs to the distro to fixing the not booting issues. For example, we found that Debian 10 doesn't support all IMS 7 and 8. So we issued a bug report, and that makes Debian 11 can be boot on IMS AM and now.
Okay, so to install Debian, we download the ISO image from the official site. So download the ARM64 ISO image, and you can directly DD the ISO image onto a USB stick and insert the USB stick to the board, and you can boot the board. So that's how we are going to demo this. So the board will put into the Debian installer. And you see the Debian installer, so you answer the questions step by step. Then you can install Debian. So basically that's it for Debian, right? And for OpenSUSE, we can download the lib. So yeah, it download the lib. And it's also an ISO image. I download this one network image, so it's an ISO, and you also directly DD it to the USB stick, and you can put the board. And it enters to the OpenSUSE lib installer. So wait for a while, and yeah, it's a bit slow, but just wait, and you will enter the installer. Yeah, there are some errors, but it's okay. It's just a hardware crack. So yes, you can see that we have the installer runs. So yeah. So yeah, that's basically the demo. So we can also install the OpenSUSE by this way.
I'm Masami Hiramatsu, Senior Tech Lead for SocialNext Landing team. So SocialNext Landing team is working on our platform SDK project. This project has two goals. One is using the latest standards, and the other is the best mix of the security features. Today, I would like to focus on the SystemReady IR part. So here is our target hardware. Socionext DeveloperBox, which is a 96 board enterprise edition board. This is a bit unique compared to your C board because it's like a PC. So we can expand memory by DDR, and it has many peripherals like PCIe, USB, SATA, and eMMC. And this one has a EDK2 based official UEFI firmware with old SCP firmware and the TFA. So what is required for the SystemReady IR? Here is a dependency tree of the SystemReady IR. You can see that the SystemReady IR required to run an ACS test suite and install unmodified operating system and run a capsule update. Thus, we worked on these items. So what we did for SystemReady IR on the DeveloperBox. So for U-boot, we did upstream and mainline support for DeveloperBox. This includes PCI Gigabit Ether, I2C SPI drivers, and also ported device trees from EDK2, since Linux expected that, and also configure the capsule update and fix some upstream bugs for device and EFI. And for the SCP firmware, TFA, OPTI, we just upgrade these to our mainline version and fix some bugs. And also, we enable TFA TBBR support, but this is still out of tree and under development. Oh, sorry. And for the ACS, we run our ACS test suite. This one is beta version and report bugs. And also install doing that OS installation test with some distributions. Fortunately, the DeveloperBox kernel is well supported in Linux, so we don't need to change any distribution side kernel. Okay, here how we configure the U-boot and some tips we found. The U-boot SystemReady IR is somewhat easy because the upstream U-boot supports required features. What you need to do is following the official documentation here, and you need to configure some features, like a config capsule update, which requires also requires DFU out info setting, and also configure EFI ignore OS indications. This is a good option for capsule update support. Also, U-boot must provide the device tree to grab and Linux. Of course, you can prepare the different device tree from the U-boot device tree, but in our case, we use the same device tree with the U-boot and the Linux. So you need to configure that config OF control and config default device tree so that U-boot can pass it. Also, the distribute is a good option because this tries EFI boot at first on the device and easy to enable that. So you can follow that this documentation, the doc readme distro file to enable that. Here are the other tips and pitfalls for the configuration. For the RTC, actually that official documentation asks you to enable that the RTC emulation, but if your platform has a real RTC, you should disable that. because disable that the emulation option. Because that which introduce a dummy RTC, and you may lose the real RTC control. So, and also for the EFI file system, U-boot EFI will detect not only EFI system partition, but also Linux partitions. This may affect ACS file system tests, which run read and write and read dir, etc. on the file system. However, since U-boot supports full operations only on FAT, so if you it found that the ext4 or something like that, it will the test will fail. So I recommend you to uninstall Linux before ACS or only enable the FATS file system support. Also, you may find configure EFI capsule update on disk early option. What is this? This option will detect capsule file at U-boot early stage. At that point, only embedded device, the device is listed in device trees, is available. Something like eMMC or something like that. So if you do a capsule update from USB or SATA or NVMe, you must disable this early option. Also, U-boot sometimes doesn't find, actually that it could be don't find the capsule file on the FAT partition. Why? Because the capsule file must be stored in an EFI system partition. So if you use a USB flash device, you need to, not only format the flash disk partition with the FAT, but also you need to initialize the partition as a EFI system partition type. You can do it by your some GPAT8 or something like that. So at last, I would like to tell you what the EFI capsule update and how it is implemented in U-boot. The EFI capsule update is allowing you to update the firmware using capsule file. There are two ways to do it. One is the capsule update via EFI APIs. This is usually used in EDK2, but U-boot doesn't support it. So the other is a capsule update on disk. You would support this, and you will put in this case, you will put the capsule file under EFI update capsule directory in the EFI system partition. Then at the next boot, EFI will update the file firmware using those files. So here, you would support two types of capsule files. One is a raw format, and another is a fit format. Actually, on the DeveloperBox, we use only the raw capsule format. This format is simple and flexible because we can put several files under the directory. So user can choose which firmware is updated. By the way, how the U-boot implement the capsule update? The key is the DFU, device firmware update. The DFU is a firmware update protocol over USB or network. This one is special for the U-boot device firmware update. And it actually has a front end and back end. The front end is a USB gadget driver, and back end is a what's it, the backend storage driver setting. And backend has is configured by DFU alt info. The DFU alt info is the setting command. Setting via environmental variable. And it has some interface and device ID and FW firmware name and the offset and size. So that you can set that several firmwares partitions on that. So U-boot EFI capsule update is implemented on the DFU. So you need to set up the DFU alt info. And DFU alt info is reused by your EFI capsule update. Actually the EFI capsule update using the firmware identify that the firmware not only by name but also that index number. So this DFU alt info has several entries, and each entry has an index number. So on the DeveloperBox, I set that DFU alt info as this. So we use that MTD interface, and here is a device name, and we have three firmware partitions: U-boot and FIP and Opti. Yeah, this one is external Opti. So to generate the capsule file, you can follow this instruction. The U-boot has a MKEFI capsule tool. Currently, it only supports just one file. Actually that's a low low capsule file. Actually that you can add some files on the one capsule file. But currently the MKEFI capsule tool only support one file for the one capsule file. Actually, the capsule update on the DeveloperBox, you can follow this instruction to upgrade the capsule update. So that's all from my side. Thank you very much for our presentation. If you have any questions, please feel free to ask us.